Hey everyone, and welcome to another Risky Business video product demo. My name, of course, is Patrick Gray, and today we're going to be taking a look at Stairwell. Stairwell is a relatively new company founded by Mike Wiacek, who'll be joining me in just a moment. And the idea behind Stairwell is they get a copy of every single file in your organization by using a file forwarder that is installed on your endpoints. And then they can do a bunch of file analytics once they have all of these files into a single corpus. And that can be things like you can do your Yara hunting there. You can look for variants of known bad stuff. You can get all sorts of interesting metrics and analytics. And it's useful in a bunch of different ways. So Mike, how did I do explaining the basic concept of Stairwell there?
That's actually not too bad. We are a platform that's pretty novel in its approach. We do, our goal is to collect all the executable files from every machine within an enterprise, record where they came from, what their file names, what their paths were, and then we do a lot of processing of those files out of band. And happy to be here today and show you a walkthrough of what the product looks like.
All right, let's bring that up now. So here we go. What am I looking at here?
Okay, so this is like just the main dashboard. Some overview of how you should think about Inception is that we are built for multi-tenancy almost by design. So MSSPs and MDRs tend to really love what we're doing, but you can actually use that capability even if you are a larger enterprise and you want to segment things off your executives' machines as one particular set, or you want to go by organization. So up here in the left-hand corner, we have what we call the environment picker, and this particular account that I'm logged in with has access to Escalator Corp. We use this for our demos. And then you can see they segmented off EMEA, JPAC, and North America as separate environments. And I can come here and just click these on. And what you should think about these are as almost like, I'm going to really date myself now, as transparencies on an overhead projector. When I turn on different environments, I'm looking at the union of all of these different environments together as if they were one giant environment, if you will. If I was an MDR or an MSSP provider, this could be customer 1, customer 2, customer 3, and I can actually hunt across all of them in one single UI. And
I mean, it's like let me just congratulate you, because obviously I've worked with a lot of vendors, and the MSP market these days is actually pretty big. So a big thing that a lot of new vendors have to do is re-engineer their product to support multi-tenancy. Like, no one builds this from scratch. So kudos. I salute you for actually thinking of that out the gate. So that's cool.
Thank you. That was there's lessons learned in previous lives where you're like, you inevitably get there, and it's always harder to add it on after the fact than build.
Yeah, no, exactly. That's why I'm like, okay, that was some good thinking. A stitch in time saves 9, as they used to say. But do go on.
Yeah. So I can turn those on. We have a bunch of different malware feeds embedded into the platform as well. So right now I'm just looking at, you could think of as Escalator Corp's files. But if I click this box, you're going to see a whole lot of other data show up for Malware Bazaar, Jotty, Virus Share, so on and so forth, where now I'm looking at the union of all of these malware feeds in conjunction with the files in my particular environment. And then we have a set of rule feeds down here, which are just basically feeds of Yara Rules, which I can turn on and turn off. But I'm gonna turn all that off there. Actually, let me turn this back on for 1 second. You see when I turned on the corpus here of all the different malware, the dashboard updated to show you within my selected environments, the number of files flagged by AV was over here. And if I turn that off, it goes down to 0 because Escalator Corp doesn't really have that much malware in it. Our Escalator Corp environment is fairly small. We always like to joke Escalator Corp is the nemesis of the Stairwell Corporation. So
I figured it was something like that, right?
Is
there Elevator Corp as well?
Oh, that's going to be the competitor to Escalator Corp for next round of demos. We're looking at data over the last 7 days. There's one new Yara rule. One new Yara rule match in our particular environment, and we'll go dig into that. But there's about 200 machines. There's 153 Windows 11 machines, and then another 50 Mac machines in this particular environment. I'm going to jump over to the Yara rules here because this is kind of where the platform kind of starts to shine. And Yara is built into our platform. In fact, it's the original way that we were using our system for discovery or hunting or searching and so on and so forth. If I click on a Yara rule, you can see it pops up in the right-hand detail panel here. And this is a rule that we wrote really for demo purposes. And we called it the methodology rule for potential credential harvesters. So we're looking for files that are small, under 33 kilobytes, are Windows executable PE files, are unsigned, and contain the string accounts.google.com. And the idea here being like, again, this is hunting, right? Where this isn't looking for known bad stuff. But the idea is if you had a small executable file that referenced accounts.google.com, it's probably going to be signed by Google or another trusted party. Why would you have such a small executable file that references that string?
No, man. I mean, the reason I just laughed a little bit there is because I'm like, yeah, that's going to find you some good stuff, right? Like, if you get a hit on that, it's worth investigating.
Exactly, and that's the idea. So these are some of the things that like we enable where you don't have to go straight for the good or bad. Like if I have a, I won't name any particular product names, but if you have like a well-established, top tier EDR platform installed, and they say something is bad, you should probably just go deal with it, right? Like trying to second guess that is probably not the best use of your time. I want to try, how do we help people go look into the gray area, if you will, and go look for those spaces where it is a little bit more suspicious by using things like this methodology rule here.
Yeah.
So, this rule gets deployed. I can show you, I can come here and click edit, and I can just go change it. And if I, put quotes there, remove a quote, you see there's a red underlining in there, and it's basically the editor we have here is Visual Studio Code's editor. I think it's called Atom. And we taught a little bit about Yara so that, if we make some typos in our rule, we get underlined there, so we actually know that we're writing probably a bad rule that won't compile. If I was creating this rule from scratch, I can come here and do a test scan. I can say, hey, this rule must match a set of certain hashes and must not match other set of hashes, and I can go over and do a test scan. So just to get an idea, is this rule going to do what I expect it to do when I actually go out and deploy it? If I were to submit it, that would take that rule. It would send it through several I think it's 50 gigabytes worth of known good software, making sure that we don't match anything that's well known, well established as good from reputable vendors. And then if that passes, it goes over and starts scanning every file that we've ever collected from Escalator Corp. And that's the key part. It's not just the point in time forward, but it's the long tail that we've had in the past. And this becomes really interesting when you look at things happening like the SolarWinds attack or Log4j even. Companies that were using our platform wrote Yara rules looking for the vulnerable versions of Log4j, deployed it, and instead of spending 6 months hunting down for cases where they had Log4j on their machines, they came back and in an hour or two, they had a list of every copy of Log4j on every machine in their fleet, historic or current. And that made a really hard security problem much, much easier. In this particular case, for our credential harvester rule, there's one match at Escalator Corp. And if I click that, I see this file over here on the left-hand side. And we see, if I click on the hash, we see some details about it. So there's a file here that's 34076E. It has no AV verdicts. It matches that potential credential harvester string. But here's where you get really cool. This file exists or existed on two machines, Jack Win11 and Cynthia Win11 at Windows Notepad.exe. Totally doesn't look that suspicious at all, right?
Yeah.
Details, you can come in here, you see your usual hashes to identify stuff, import hash. Sorted import hash is a small take that we did to import hash where we collect the import string, but then we alphabetically sort it before we MD5 it. This way, if anyone tries to manipulate the import table, we actually are able to be resistant to shuffling them, and you now have a more stable way of finding it. When did we first see this file? Inception first saw it September 14th. Escalator Corp first saw it same time. So Escalator Corp was the first people to have that file. It contains two host names, updatersystems.xyz and accounts.google.com. Both were extracted from dynamic and static analysis. And then we have some IP addresses that were extracted from detonation data.
So hang on, you're doing your own dynamic analysis on these files, are you?
It's possible. So you can come over to the detonation tab and you can click detonate if it hasn't been detonated already, and we will go over and detonate that.
What are you using for that? Because I'd imagine you're using a third-party sandbox to get that info.
So for right now, we're using a third party, but we're actively looking at making it possible for people to bring their own sandbox, which is a common request from customers. They may have already procured some service, so we're trying to normalize that interface, and then you can have a choice of sandboxes to go down.
Well, and it's one of those things where sandbox choice is kind of one of those personal things. Oddly enough, you know what I mean? It's like people are used to the output. They can look at it in a second and be completely across it. And you throw them into, the next most popular sandbox and they're like, this is all confusing. I hate it. Basically, exactly. Even though it's basically the same thing,
Exactly. And so we started off, right? As a young company, you pick your battles, and so we said let's just go with one vendor for right now. But the idea is very shortly be able to roll out to support multiple vendors. We'll bring back the data, normalize it for our UI, and then it will come in there. So even if it comes from Sandbox 1, 2, or 3, you get the same data populated here, and it just comes in and enriches.
Yeah. Got it.
All your fun technical PE data is all listed there, and you can go do stuff with it if you want. You can see a hex dump of the file. These are the strings that are contained within this particular file. We do rank these based on a heuristic for interestingness. And so you see at the top of the list is a base 64 blob. I always like to call out this string here, failed to DNS lookup on TGT server. That always catches my attention. You have your
what do they mean by TGT?
What could it be?
Yeah, exactly, right.
And then there's an OSINT tab where this basically does a Google search programmatically for the MD5 SHA-1, SHA-256 hashes to see if there's any mention of it in any sorts of blogs or anything along those lines there.
Yeah.
But when we come back here, here's where we differ. Lots of platforms, tips will have some of that type of data there. Here's where we go a little bit different is I can click Cynthia Win 11. And now what I'm going to be getting on the panel over here is this is a list of every executable file that's ever been on Cynthia's computer. We know because, we're running Escalator Corp, there's 153 Windows machines. And so when I see a file like this that lives on 153 assets, it's probably not bad. And if I come in here and I click on it, I can see, this is almost definitely a legitimate Microsoft system file or so on and so forth. We look at the details. We can go over it.
Well, yeah, you want to start with the exotic stuff, right? The stuff that is less common. Yeah.
Bingo. So we came here and we started off with this file here, which matched that rule. But if you take a look, that's 16K. It's on 2 assets. And there's another file that's also only on 2 assets that is also 16 kilobytes. This is that visualization layer I was telling you about before. You look at those first 2 files, you see they look damn near identical compared to the variety that you have in everything else there. So I'm going to come over here and let's take a look at that second file.
We should just mention too on the visualization stuff, because I don't think we actually spoke about it in this part of our recording. But yeah, you can just get a visual output for all of the files listed there, and you can say, okay, well, those two do look actually quite similar. So those two 16K files, you can pretty much say, yeah, they're variants of the same thing.
Exactly. So we pull that up. We look at the second file. This file's on Cynthia Win11 calcback.exe and now Victoria Win11 calcback.exe. And see, we're kind of able to slowly pivot through our enterprise and see where these files are. If I take a look at the details, I don't see accounts.google.com, which is why I didn't match my Yara rule, but I see buyflights.shop and facebook.com. I see some IP addresses in there as well from dynamic analysis. And then
and that makes sense, right? Because what they've done is they've changed, it's targeting Facebook accounts, but that's broken the hash, which is why it didn't, and it also won't get matched on the Yara rule that led you to the original thing, but, it's totally the same thing, just targeting a different service. So that's, yeah.
Exactly.
Perfect example for a demo, Mike. This is awesome.
Yeah, wonderful. One of the things here is you look at the strings in this file, you see that same base 64 string and that wonderful error for failed to DNS lookup. I'm going to copy that and we'll come back and play with that one later. So now where do I go, right? I can come over and I can look at Victoria's computer and see, does she have anything else that's weird? And there's only everything else is pretty common except for that there. But, let me come over and say, let's pivot off the import hash for these guys now. So if I come over here and I click on the import hash, you're going to notice up here the search query changes to object.import hash equals 259dd whatever. And it finds 3 files. It finds the original one that matched that credential harvester rule we started from. It matches the new one we were just looking at over here. And then there's a third one that's only on one asset. If I come over here and I check on that one, you see this is explosiveart.xyz, and you see a reference to myaccount.microsoft.com. So you can clearly see there's some stuff there. We come look at the strings. There's our TGT
Hang on,
server.
so how is that matching on a hash if it's actually the content is different?
Yeah, so this is using Mandiant years ago wrote a blog post where they described what they called an import hash, which is basically extracting the imports that an executable file uses and then turning that into a string and then just hashing the string. So if I come back, so if you take a look at import hash 259 and I click on all three of these, they all have the exact same import hash. And so
so I'm not in the weeds enough to know what an import hash is, but that makes a lot of sense. And I'm guessing I just cleared that up for a few of our viewers as well.
I appreciate that. So now we're able to just like click on one of them. And technically, if I click on that, you'd find 3 different variants of this file within our enterprise. And this new one here, on what computer is it living? It's on George Win11 at kernel64.exe. We can add some tags to it and so on and so forth. Here's where I talked about the idea of we can turn on these like different environments to overlay almost like a transparency projector would. Let's come back here. Look at my search query. It stays the same. I have 3 matches, but now I'm going to come over here and I'm going to turn on some malware corpuses. I go bing. And now what you see is, hey, there's 2 other files. They're on 0 assets because they don't exist at Escalator Corp. They only exist in malware feeds. And if I come here and I click on this guy here, you see this one matches some of the AV engines that we're scanning with here. This one came from VxIntel as well as Malware Bazaar. It looks like it hit Malware Bazaar before VxIntel. This has supericehockey.pro, hotmail.com. And if we go look at the strings, we're going to see our favorite little string there, TGT server, ready to go play with. So now, like, it's really kind of cool, right? With like out having to do any real reverse engineering analysis. If I look at my pictures, I say, yeah, these things all look damn near identical. I found 3 instances of those within my environment. And it was all kind of predicated on having a fairly broad, but at the same time, fairly targeted Yara signature that identified some suspicious stuff within my enterprise. But let's say I wanted to write a better Yara rule to match TGT server. I can come to my rules panel. Oh, I should point out here, now that we turned on our malware feeds here, you start seeing for these particular strings, like credential harvester, there's 78 matches in VxIntel, 4 in Malshare, 1 in Malware Bazaar, 1 at Escalator Corp, 21 in Joti. You basically come over and now you're running those rules across all those different environments concurrently, and you're seeing.
No, I mean, I think it's an interesting way that you've done that, because to just treat those corpuses from those feeds as just any other file, but you know, when you're doing your slicing and dicing and searching and whatever, just display them the same as you would anything else, or you know, but change the color to red. You know, it's an interesting way to do it. I like it, because I think quite often people building a product like this might draw, you know, have a different workflow for searching one versus the other. Just lumping it all together kind of makes sense.
Mm-hmm. Yeah. So now, like, how do we make a new rule? I come up, make my rule. I can call this TGT strings. This is just, you know, trying to type while recording is always fun. I can just, you know, I'll just call this, you know, A equals that string there, and then just say condition $A. And if I were to, I should have saved one of those hashes for it. Let me see if I can go back and grab that real quick. Escalator Corp, copy that hash, come back here, new rule. Oh, I lost it. No, demo fail. I'll just say hash equals, I'll put that hash in there. And then, you know, just say TGT server just for sake of time. TGT server, and then say my text string, call that done. Now, technically, this rule should match this file, so I can go prove that test scan thing works and say, hey, this rule must match that. Let's kick off a test scan. And yes, that rule matches that hash. And so now I could go deploy that, and I'd come back and I'd see matches and do short time. That's really fun, right? And this is a pretty, in some sense, a pretty advanced workflow. People say, what if I'm not going to write my own Yara rules or so on and so forth? That's fine. But, you know, it feels like every day somebody, some security blog is putting out Yara rules for something, like put them in there, see what you have, right? Like, especially when you have scary things like SolarWinds or Log4j happen, it's a great way to do that. We also provide a whole bunch of rule feeds. If I come here, I turn this on, you're going to see thousands of Yara rules suddenly show up in your environment, and you can go dig in here as much as you want. And we're actively adding to sets of rules, and they're coming from all sorts of different places. And
I'm guessing those rules, some of them are going to be pretty noisy though.
Yes.
Like you'll run them and you're going to get all these hits on stuff that's okay.
Absolutely. So you can see here, like, looking for an embedded PE file inside of another file. VX Intel, I think, has showing you 45 million. I need a decimal point in there. 4.5 million, 45 million, whatever. A lot. 19 files on Escalator Corp. And so I can come here, I can click on Escalator Corp and get an idea. But the nice thing is, since I have that count and I know roughly how many machines I have, I'm going to assume not every one of my machines is hacked simultaneously, and it lets me go over and play around with that there. So in some sense, this is like the really cool workflow that we have. But I want to show what we're calling variant discovery, because this is where we started, and what we've added literally in May and June of this year is really transformative. So I gotta tell the story. Go for it.
I have to tell the story, which is that Mike was so excited about this that we were chatting via Signal around the time that you just got this, properly working. We were having a conversation, and I was actually laid up, bedridden with COVID-19. And Mike's like, man, can you jump on so I can show you this? Right? Like that's, I'm like, man, I'm in bed with COVID. No, I can't. But like, I'm just mentioning this because your enthusiasm for this, to give people a sense that your enthusiasm for this is absolutely, I can put my hand on my heart and say absolutely 100% genuine.
Yes, I'm really excited to show this off here. And I haven't shown you the variant and discovery capability yet. We described it, but we haven't actually seen it.
Yeah, we didn't have time to do it yet, but yeah.
So I'm just going to go back to a search page here, and what I want to show is, let me get this loaded up here. Okay, let's pretend I'm just a tier 1 SOC analyst, and I'm sitting in a SOC, and I get an alert like I have here on my screen, and I'm like, okay, what am I looking at? I see Hermetic Wiper on Olivia Win11. It's in System32 WL Nita O2S.dll. Here's the hash. And if you think to yourself, like, what would, like, if you're a CISO or you're a SOC person, you're working in a SOC, what do you do here? And in general, people would say, well, like, okay, let me go do a Google search for the hash. I don't find anything. Let me go search virus total, and I'll come here, I'll hit search, and I'll put that in there and say, oh yeah, 4268, say it's bad. I definitely see stuff for kill disk, Hermetic Wiper. Yeah, it's probably bad. Kick off a SOAR job, remediate the machine, reimage it, call it done. And one of the things that I always thought was really interesting is, if I'm going to pretend I was like a cop and I'm looking for probable cause, when I get an alert that says, hey, there's something bad in my environment, here's where it is, what I kind of think of this as is, this is what I would call like probable cause. I want to go digging around to say, is there something, in this case, Windows Defender, is there something that they missed? And it's also possible to ask yourself, when did Windows Defender start detecting this stuff? Because hypothetically, let's say it started detecting this thing, I don't know, July 1st. When did I have anything that was on any of my systems before July 1st that I don't know about, right? And that's something to really think about. Like, how often do I go back and search for signs of problems that my front level tool didn't catch at that point in time? So like that's like one of the things to like think about here. Okay, so what we're going to do is I'm going to copy the hash and show you how we can kind of play with this. I'm going to drop it into Inception, paste it in.
He's getting to the good bit, everyone.
Yeah.
It's pretty cool.
I'm going to click over to it here, and you see the details that we saw before. Context, it's on Olivia's computer, et cetera, et cetera. There's a button up here for see the variance of this object. I'm going to go over and click it. Let's close this here. Now, what's happening in the back end is we're searching over about 500 million files. not just at Escalator Corp, but also in all these malware feeds, looking for variants of this particular file. Okay, yep. So now, let's check this out. We have Olivia Win11. Her computer had the original variant on it, first seen 529.607, last seen 529.610. And then we're saying, hey, there's 3 other machines here that had a variant number 2, and the day before. And then Andrea and Beverly, which is almost over a month earlier, looks about 6 weeks, they actually had a copy of this file, 99% matched to the original back then. If you take a look at the pictures, again, we're not using the pictures for the variant analysis. It's there to help you confirm as an out-of-band signal that things look right. But if you look at the structures in here, you see the green blob with this red and black area. It's green blob, red and black area. It's still there. It's rotated around a little bit, which means the files are different sizes, and that holds true. These are 115K. This is 114K. But this where you actually get really interesting is of the 27 AV engines that we use to scan this particular file, this has 11 Yara Rules match, a lot of them for Hermetic Wiper, and it's signed. We come here and take a look at this one here. We see this file has 16 AV detections instead of 17, but of those 16, 14 overlap with the original one as well. And that's what we're trying to break out here in this little pop-up, that you're saying, yeah, there's a lot of commonality there, even if a few of the engines either fail to catch this particular variant or not. And then as far as Yara rules, 11 of the rules in the system match the original and the variant, and the same ones do the same for both. Files obviously signed. And then you have variant number 3 on these machines here. So the idea is, we may have a security product alert in our SEM for this particular variant, but if these were here 6 weeks ago, it's possible our security tools did not know to catch that thing back then. And here we're kind of using one alert today to expose that long tail history of things. But wait, there's more. If we're just looking at my objects here for Escalator Corp. If I click over here on the all objects, now what you see is everything, but now check these out. These are variants that still have, a lot of overlap with the original, but there's no asset information. These are because these are variants that exist out in the wild. Here's one where people actually added a lot of FF 255 bytes to the file to try and pad it out. It's an 11% match, but it still has a lot of AV detection overlap and a lot of Yara detection overlap. And then as you scroll down here, you see all of these. Here's a particular subset of interesting ones that these are not signed, yet they're still highly similar to the original. These are cases where people tried to add some null byte sections to the PE to try and obfuscate detections. You can definitely see some of the Yara rule match counts there.
But hang on. The obvious question is, how are you actually spotting variants? You started with a file hash, and then from there you whack it in a box, and then it goes crunch, 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 and then spits out a list of variants. How is it doing that?
Yeah, so that's the fun magic sauce there.
Because when you demo it and you say, oh, it's easy, like people might not realize that that's kind of hard.
This is really
that's not
hard.
a straightforward thing. There's not just like some directory where you can look up unknown. I mean, these are relationships that you're actually stitching together on the fly, right? So how are you doing that?
Absolutely on the fly. We're doing it by a whole bunch of things. We've taken a lot of what would be the features. Like we looked at import hash earlier. So import hash is a feature I can talk about. For your source file, what's the import hash of that file? If we scan, when we store files, we do a lot of really expensive processing on those files at ingestion time. And so for import hash in particular, when you give me a file, if it has an import hash, we'll say, what other files have that as a selective feature? Then we turn around and we say, what are the other selective features, of which there's right now probably dozens that we're pulling on, to try and build up a mini corpus or a subset of the full, hundreds and hundreds of millions of files of potential candidates. And then they get ranked through a proprietary machine learning layer, which tries to return good matches back to the caller. And so now the idea is the one thing that every security team has too much of, straight off, is alerts.
Yeah.
And all those alerts now become weaponized to do effectively automatic threat hunting locally and globally. So now all of these variants that exist out in the wild, we can come up here and we can say, hey, let's go tag them all. Let's copy Let's detonate them all. Right. And so I can tag them, I can detonate them, and then you can use our API to build whatever sort of integration you want. Do you want to say anything that I detonate and tag with bad suddenly goes to my proxies or goes to my DNS servers to be null routed? I'm building a system to almost operationalize active threat intelligence and threat hunting, which is really cool because this has always been out of the reach of people. And now we're bringing this into the level of, hey, I'm just a guy in a SOC looking at alerts, but I can go over and I can now do work that would have been previously reserved for high-end incident response or high-end threat.
Well, I mean, I think really what you've built here, it reminds me of when some of these early NDR sponsors, we're doing stuff with us on the show, right, where people previously had IDS and whatever, and then this whole concept of NDR, which is workflows that look more like this, right? Mm-hmm. So it's applying the same sort of thinking and the same sort of workflows to a gigantic corpus of files. And what you just said there about how you're doing this bit of it is interesting, which is the expensive processing on the way in, which is strip out the features, strip out the metadata, crunch, throw that into some sort of data store and then ML it.
Yes.
When you need to. Yeah, it makes a lot of sense, but it's just so reminiscent of these NDR style approach, right? But for completely different data.
Spot on. That's exactly what we're trying to get to. Like, how do we make it possible to like reason by analogy almost, right? The code name for our variant discovery capability was called Metaphor, and being able to say what are things that are like that. I guess simile is probably more accurate if we use the word like, but you get the point. One thing to show you, I'm going to drop another tab in here real quick just to show you is here's the original Stuxnet advisory, right? And there's a bunch of hashes here. For sake of time, I loaded it up in a window already, but hey, here's a malicious DLL that was part of Stuxnet. And dropping that in, you see right here, we have no objects at Escalator Corp. But now here are 6 variants of that. And if you take a look here, this is a signed copy. It's invalidly signed, but it was still attempted to be signed. And then here are other copies of Stuxnet that required no work. It was simply click a button on the hash and see what other stuff I have. I look at the pictures, I can see that they're very similar, but now you have places to go and poke. If I click on one of these, you can come in here. You see this came from Virus Share. You can look at the hex view. You can go with strings. You can download the file. You can do that.
I mean, have you done much of that sort of? Are you going to do much of that sort of analysis of, maybe having a look at some ransomware tooling and try to unpick it a bit, because that'd make excellent. That's excellent blog fuel.
Oh yeah, I mean, it's actually really fun whenever we see anything new hit where people are posting hashes or so on and so forth. It's fun to grab those hashes, drop them in here, and see what else exists. Because the idea that any report is exhaustive or logically complete is simply just not true, right? You need to be able to scan not just malware feeds, but the files that exist within your own enterprise. And so that gives every user of our platform a fairly unique view or aperture into the security landscape. Because, what's the difference, right? If I'm looking for things that are similar to known bad, whether or not that bad stuff exists here or there, I'm still looking. And if I can look in both places simultaneously, I'm going to find a lot more interesting stuff. And we'll see where that goes from there.
All right. Well, Mike Wiacek, I figure if people aren't interested by now, then this tool maybe isn't for them. And if people want to know more, then I'm guessing it almost certainly is. So I think we'll wrap up the demo there. Thank you so much for joining me to walk me through it. Very impressive demo. And I wish you all the best with it. Cheers.
Cheers. Thank you.